Distance travel is the speed with which you are traveling and for how long. In short, d is equal to st, so speed is distance by time, time is distance by speed. The first checkpoint will be average speed. Average speed is given by total distance divided by total time. Let us look into the example. A taxi covers 60% of the distance at 30 miles per hour, 20% of the distance at 20 miles per hour, and the rest at 10 miles per hour. Find its average speed. Because the distance is given in terms of percentage, let us take the distance as 100 miles. Then the total time is 60% of the distance is 60 at the rate of 30, 20% is 20 only at the rate of 20. The remaining is from 100, if you remove 60 plus 20, 80, 20 miles are remaining at the rate of 10. That gives you 2 plus 1 plus 2, 5 hours. Therefore, the average speed is equal to total distance 100 by 5 hours, so 20 miles per hour. A man covers distance of 300 miles in 5 hours. The next 200 miles at 40 miles per hour, and he travels for the last 3 hours at 50 miles per hour. Find his average speed. Total distance will be 300 plus 200 plus 3 hours into 50, that is 500 plus 150, total 650 miles. And if you look at the total time, it is first 5 hours, next 200 at 40, the last 3 hours, that makes it as 13 hours. Therefore, the average speed is equal to 650 at the rate of 13 hours, that is 50 miles per hour. One familiar example we can see. A man covers distance from A to B at the rate of 60 miles per hour and returns by the same way at the rate of 40 miles per hour. So find his average speed. Since the distance, speeds are given in terms of 60 and 40, let us take the distance as the LCM of 40 and 60, which will be 120. So total distance covered will be 120 one way and 120 return, total 240 miles. And if you look into the total time, one way 120 is covered at 60, the return 120 is covered at 40, so we'll get 2 plus 3, 5 hours. Therefore, average speed is equal to total distance by total time, that gives you 48 miles per hour. Here one thing you have to note. average speed is not equal to average of the two speeds. A to B, let us take the distance as D. So, total distance will be D plus D 2D. Let us take one-way speed as x miles per hour, written as y miles per hour. So the total time taken would be d by x one way and d by y another way. If we simplify, what we get is t into x plus y by xy. So we can find the average speed, total distance of 2d divided by d, x plus y by xy, d cancels. So we have a rule saying average speed is 2xy by x plus y, only when this distance covered on either direction is the same. Also, it's not necessary to travel the entire distance and come back. You can cover off distance d by 2 at the rate of x miles per hour, another of d by 2 at the rate of y miles per hour. Then also the average speed is given by 2xy by x plus y. In case the distance is divided into 3 equal parts and then traveled at 3 different speeds of x, y and z miles per hour, then the average speed is given by 3xyz by xy plus yz plus zx. That's about average speed. Let's look into the other factor, sums on time difference. Walking at 5 miles per hour, a boy is late to his school by 5 minutes. If he walks at 6 miles per hour, he is early by 5 minutes. Find the distance. The time difference is 5 plus 5, 10 minutes. 5 minutes late to 5 minutes early becomes 10 minutes. So, time taken in the first mode of travel, then the second travel is 10 minutes. Time 1, distance by speed 5, distance by speed 6, 10 minutes convert into hour, divide by 60, because speeds are given in miles per hour. The average is 30. 60 minus 5d is equal to 1 by 6, or we get distance is equal to 30 by 6, 5 miles. A train traveling at 40 miles per hour reaches its destination punctually if it runs at 35 miles per hour instead. It is late by 15 minutes. Find the distance. Let the distance be d. Then what is the time difference here? The time difference is 15 minutes. It happens because if you are traveling at a lesser speed instead of original speed of 40, you take 15 minutes longer. The LCM is 280, 8 times of d and 7 times of d. This is 1 by 4. So d will be 280 by 4, 70 miles. covers a distance of 840 miles at a certain speed. If the speed of train is 10 miles per hour faster, it will take 2 hours less to reach. Find the original speed of train. Let us take the original speed of train to be x. The time difference is 2 hours. Time 1 is more than time 2 by 2 hours. Distance at certain speed x or increased speed x plus 10, the difference is 2. The distance is given to be 840. So 840 by x plus 10. You have to make the right side 1. So divide by 2. 420 by x and 420 by x plus 1 is equal to 1. Sorry, x plus 10. This is where you have to stop. If you make it a quadratic, the number becomes 10 times more. So the easy way to do is plug in from the answer choice or try to break the number 420 into factors. You can start with 2, it will be 210, 3, 140, 4, 105, 5, 84, 6, 70, 760. We have reached the place. A difference of 10 on the left side, 1 on the right side. So the lesser value will be your answer. X is equal to 60 miles per hour. A man walking at 2/3 of his usual speed reaches his office 15 minutes late. Find his usual time taken. So if we look into the speed ratio, now versus usual, now is traveling at 2/3, usual full speed is 1, or the ratio is 2:3, then you can find the time ratio, which is the inverse, now versus usual. It will be 3:2, so it is now is taking how much longer? 15 minutes. X plus 15 is 2x. Product of extremes and means. So 3x is equal to 2x plus 30, or x, the usual time is 30 minutes. Into now relative speed. The concept of relative speed will be seen. Look at the sketch. Distance is A and B. Cyclist 1 starts from A at 7 o'clock, moves to B at the rate of 30 miles per hour. Cyclist 2 starts from A to only at 9 o'clock, moves at 45. The question is, when will C2 overtake C1? So there are two methods. Let's look into the first method, which we call it as a conventional method. Step 1 is to find the time difference. In this case, it is 9 minus 7, 2 hours. Now, all these 2 hours, cyclist 1 is traveling at 30, so you have to find the distance covered by C1 in the time difference. So it's traveling for 2 hours at 30, you would have covered 60 miles. So, at 9 o'clock, the situation is C1 is ahead of C2 by how much? 60 miles. C1 is moving at 30 and C2 is chasing at 45. This is where the concept of relative speed comes. We call it as RS in the same direction. What is RS? In 1 hour, C1 will cover 30 miles. Same 1 hour, C2 will cover 30 plus something more, 15. This excess distance covered is called the relative speed. So in this case, how do you get the difference? 15 is the difference of speeds. So from 45 remove 30, you get the relative speed of 15. The meaning is C2 can travel 15 miles more every hour than C1. Now we have to find the time taken. That is the final step. Time is distance by speed. Distance of 60 he has to cover. At the rate of 15, it will take 4 hours. From the start of second person, that is at 9 o'clock. So at 1 p.m., C2 will overtake. This method is called the algebraic method. If C2 covers the same distance covered by C1, that is when he will overtake. So equating the distance traveled, let C2 overtake C1 after X hours. If C2 is traveling for X hours, C1 is traveling for how many hours longer? C2 is traveling for 2 hours longer. Then the distance is speed into time at the rate of 30, x plus 2, same as 45x, divided by 15, 2 times and 3 times. So 2x plus 4 is equal to 3x, or x is equal to 4 hours. Very quickly we got from 9 a.m. So that will be at 1 p.m. C2 will overtake C1. Another sum. Distance PQ is 208 miles. Train 1 is starting from P at 10 a.m. moves to Q at the rate of 30 miles per hour. Train 2 starts from Q at 1:20 p.m. moving at the rate of 24 miles per hour. The question is, when will the trains cross each other? So let's go by the first method. Step 1 is finding the time difference, which is between 13:20 and 10. 3 hours 20 minutes can be written as 320 by 60 or 31 by 3, 10 by 3 hours. And step 2 is the distance covered by train 1 in the time difference. That will be 30 into 10 by 3, 100 miles. What is the distance left to be covered by 2 trains? So distance left is 208 minus 100 is 108 miles. Now find the relative speed. They are moving from the opposite direction. Look at the sketch. 100 is here, 108. They are moving from the opposite direction at 30 and 24. So it is 30 plus 24 gives you 54 miles per hour. And finally, the time taken is distance by speed. 108 at the rate of 54 will take 2 hours from 1:20 p.m. So that is at 3:20 p.m. the trains will cross each other. Distance PQ is 1080 miles. Train 1 is starting from P at 10 a.m. at the rate of x miles per hour. Train 2 is starting from Q at 1 p.m. at x plus 15 miles per hour. The question is, when will the trains meet midway? So the midway distance we know is 1080 by 2 is 540 miles. So distance we know, they are meeting midway. We have to find the time when do they meet. So like before, let's find the time difference, which is 1 p.m. to 10 a.m. is 3 hours. So the equation here is time 1 is how many hours longer? 3 hours longer than time 2. So 540 at the rate of x, instead of x plus 15, you will take 3 hours. We have to make the right side 1, divide by 3, so 180 by x. 180 by x plus 15 is 1. This is where we'll stop and go for the factors of 180. 2 into 90, 3 into 60, 4 into 45. We have got the difference of 15 and 1. So the speed of the train is 45 miles per hour. And from there we have to go for the time. 540 at the rate of 45 will take 12 hours. From when? From 10 a.m. So the trains will meet at 10 p.m. in the night. Circular tracks. A and B. A and B start at the same time from the same point. Travel in the same direction around a circular track of circumference 1200 meters. First question is, when will they be together? Should they? For the first time. When will they be together for the first time? The rule says, find the relative speed in the same direction and the time taken, cover one round with that speed. Relative speed in the same direction is 150 minus 50 is 100 meters per minute. So time is distance by speed. 1200 by 100, 12 minutes is the answer. Answer, in 12 minutes, A will cover 12 into 150, 1800 meters. In terms of circumference, 1200 plus 600, 1.5 round, that means is halfway. B will cover the same 12 minutes, 12 into 50, 600 meters. So both are at 600 meters after 12 minutes. The second question is, when will they be together? For the first time at the starting point. To come to the starting point, you have to complete certain rounds. So the rule says, find the time taken by each to complete one round. Then the required time is their LCM. Time taken by A is 1200 at 150, it will take 8 minutes. Time taken by B, 1200 at 50, he will take 24 minutes. So, the required time is equal to LCM of 8 and 24. It is 24 minutes. Man 1 starts from pre at 6 a.m. and reaches Q at 10 a.m. Man 2 starts from Q at 8 a.m. and reaches P at noon. Question is, when will they meet? So we find P and Q are covering the distance, rather M1, M2. Distance PQ at the same time. Therefore, speeds of M1 and M2 are the same. Let's take some distance. Let's PQ be 28. So man 1 will be halfway, which is 14 kilometers. The speed of first person and second person, 28, they are traveling in 4 hours, so 7 kilometers per hour. So at 8 o'clock, M1 is at 14 kilometers. The distance left is 14 kilometers. Relative speed is 7 plus 7, 14 kilometers per hour. So time taken is distance by speed, 14 by 14 is 1 hour from 8 a.m. That is at 9 a.m. M1 and M2 will meet. Time and distance we call it as 2, which is called ports and streams. A stream is a small river. So if you draw the sketch of a river, if you are sailing or rowing a boat or swimming in the direction of the current, it's called downstream, and if you are sailing against the current or swimming against the current, it's called upstream. Convention is to take speed of man or the boat rowing as x miles per hour. Speed of the stream is y miles per hour. What will be the relative speed? If you want to look at downstream rate, it is x plus y. You are moving at the rate of x and the water is moving at the rate of y, so it will be x plus y. And if you have to come up the stream, you have to overcome the speed of y, so it is x minus y. For convenience, if we call them a and b, then x will be sum of the equations by 2 and y will be difference by 2. So, if we look at sum of the equations, x plus y is 7, x minus y is 1, x will be 7 plus 1 by 2 is 4, and y will be 7 minus 1 by 2 is 3. A man rows 24 miles upstream and 28 miles downstream in 6 hours. And he rows 30 miles upstream and 21 miles downstream in 6.5 hours. Find the speed of stream. So the equation is 24 miles upstream, x minus y, 28 miles downstream, x plus y is 6, call it as 1, 30 miles upstream and 21 downstream is equal to 6.5. You solve it simultaneously. Equation 1 multiply by 5, 120 by x minus y plus 140 by x plus y is equal to 30. Equation 2 into 4, again 120 by x minus y, 84 by x plus y is equal to 26. If you subtract, you get 56 by x plus y is equal to 4, which means x plus y 56 by 4 is 14. Substituting in 1, 24 by x minus y, 28 by 14 is equal to 6, which means 24 by x minus y is 4. So x minus y is 4. So if you have x plus y is 14, x minus y is 6, then y will be 8 by 2, 4 miles per hour. Also on boats and streams, a man rows 1 mile in 1 hour and returns in 45 minutes. Find his speed. 1 mile taking 1 hour is down upstream, is 1 hour, and 1 hour taking 45 minutes should be downstream. So what we are getting is x minus y is 1 and x plus y is 4 by 3. If you want x, it is sum of the equations by 2, that will be 7 by 6 miles per hour. A train traveling with uniform speed crosses a platform of length 750 meters in 15 seconds and crosses a bridge of length 1.8 kilometers in 30 seconds. What is length of this train? When a train travels or covers a platform, the distance covered by the train is length of the train and the length of the platform. Let the length of train be x meters. So 750 plus x in 15 crosses a bridge 1.8, 1800 meters plus x by 30. Solving x is equal to 300 meters, it is 0.3 kilometers. Downstream in 8 hours and 40 kilometers upstream in 6 hours. Find the speed of stream and the speed of boat in still water. Let the speed of boat in still water be x and the speed of stream be y. Then downstream 60 kilometers in 8 hours will become 60 at the rate of x plus y is 8, which means x plus y is 15 by 2 and 40 40 at x minus y is 6. So x minus y is 20 by 3. Adding and dividing by 2, x will be 15 by 2 plus 20 by 3 by 2 will be 7.08. Y will be 15 by 2 minus 20 by 3 by 2, 0.42 kilometers per hour. Let the tail be 2x and 2x, so total distance John covers is 2x plus 2x is 4x. So of the distance will be x and x. So average speed is total distance by total time, x at 40, x at 60 and 2x at 52. The average speed is 4942. The average speed of a train. With stoppages is 75 kilometers per hour, and without stoppages is 90 kilometers per hour. How many minutes per hour does the train stop? So distance lost ratio is equal to time lost ratio. Without stoppages, the distance covered is 90 kilometers. With stoppages, distance is 75 kilometers. Distance lost is 15 kilometers. Therefore, 15 on 90 into 60 is the time lost. So that will be 10 minutes. A certain distance by bus at 40 kilometers per hour and the remaining half by train at 60 kilometers per hour. John returns to the starting point riding on a scooter at 52 kilometers per hour. Find his average speed for the whole journey. So let John cover x kilometers distance by bus, x kilometer distance by train, and 2x by scooter. So the total distance become 4x. Average speed is equal to total distance divided by total time. That is 4x by x at 40, another x at 60, returning to s at 52. So cancelling x, you get 1 by 40, 1 by 60. So that will work out to 49.92 kilometers per hour. Crosses a platform of length 750 meters in 15 seconds and crosses a bridge of length 1.8 kilometers in 30 seconds. What is the length of the train? Let the length of train be x meters. Then distance covered by the train is length of train plus length of platform. Equating the time, x plus distance by equating the speed. X plus 750 by 15 seconds. X plus 1.8 kilometers, 1800 meters by 30. Simplifying, we get x is equal to 0.3 kilometers, which is 300 meters. Stoppages is 75 kilometers per hour, and without stoppages is 90 kilometers per hour. How many minutes per hour does the train stop? Distance covered without stoppages is 90 kilometers. Distance covered with the stoppages is 75. Therefore, the distance lost due to stoppages is 15 kilometers. So, distance lost ratio is same as time lost ratio due to stoppages. So, number of minutes lost due to stoppages per hour will be 15 on 90 into 60. That is 10 minutes. Not one signal poles are arranged such that the distance between two consecutive signal poles is 0.1 kilometers, and a train 240 meter long crosses them completely in 45 minutes. Then what is the speed of the train? The distance between the first pole and the last pole is 600 into 0.1, which is 60 kilometers. The length of the train is 240 meters or 0.24 kilometers. So total distance covered by the train is 60.24 kilometers. Therefore, speed of the train is equal to distance in 45 minutes divided by 16 to convert into hour. So 3 by 4, that will give you 80.32 kilometers per hour. Start driving cars in the same direction at 36 kilometers per hour and 15 meters per second respectively. In how many hours will they be 100 kilometers apart? Speed of Ram is 36 kilometers per hour. Speed of Shyam is 15 meters per second. 15 into 18 by 5, 54 kilometers per hour. Relative speed in the same direction is difference of speeds. So 54 minus 36, 18 kilometers per hour. So the time taken for the trains to be 100 kilometers apart is equal to 100 by 18, which is 5 by 9 hours. The uniform speed crosses two women coming in the opposite direction at 2.4 kilometers per hour and 6 kilometers per hour in 45 seconds and 30 seconds respectively. Find the speed of the train. We know speed is inversely proportional to time. Let the speed of train be x. Since the speed of the train is the same in both the cases, and distance is proportional to time, so we get x plus 2.4 by x plus 6 is the time ratio. Solving, we get 5x plus 12 4x plus 24, or x, speed of the train is 12 kilometers per hour. Railway platform, which is 200 meters long. He finds that a train with a uniform speed crosses the platform in 12 seconds and himself in 4 seconds. What is the length of the train? We know distance is parallel proportional to time. So x plus 200 by x, where x is the length of the train, is 12 by 4. That will give you x is equal to 100 meters. In a city, and then increases its speed by 1/4 of its original and reaches its destination 40 minutes early. Had it done the same 10 km earlier, it would have saved another 5 minutes of its time. Find the total distance traveled by the car. Let d be the distance. Traveled by the car. After increasing its speed, and s be the original speed. Total distance 25 plus d. Time is 40 minutes less. Therefore, 25 by s plus d by 1.25 s is equal to t minus 2 by 3, where t is the usual time taken. Also, 15 by s plus d plus 10 by 1.25 s is equal to t minus 3 by 4. Solving, we get d is equal to 80 kilometers. Therefore, the total distance is equal to 80 plus 25 is 105 kilometers. Two stations A and B is 600 kilometers. One train leaves station A towards station B at the average speed of 54 kilometers per hour. After an hour, another train left station B towards A at the average speed of 66 kilometers per hour. The distance from A, where the trains meet, is the time difference between the trains is 1 hour. In 1 hour, train from A to B would have covered 54 kilometers. The distance left to be covered by the two trains, 600 minus 54, which is 546. Relative speed in the opposite direction is sum of the speeds. They are approaching at the rate of 120 kilometers per hour. Time taken is 546 by 120 gives you 4.55 hours. Therefore, the distance from A at which the two trains meet is 54 into 4.55, which is 245.7 kilometers. So the options are wrong. Smith covers a distance of 90 kilometers in 45 minutes by traveling at a speed of p kilometers per 9 minutes, p by 3 kilometers for the next 18 minutes, and the rest of the time with speed of p by 4 kilometers per hour. Find the speed of the value of p. Total distance covered is 90 kilometers. So you can write 90 is equal to P into 9 by 60, converting into hours, P by 3 into 18 by 60, and remaining will be 18 minutes. So if you take P out, you get 3 by 20 plus 1 by 10 plus 3 by 40. So simplifying, P is equal to 90 into 40 by 13 kilometers per hour, converting into meter per second, multiply by 5 by 18, we get 76, 12 by 3 meter per second. Kilometers per hour in still water. When the river is running at 0.6 kilometers per hour, it takes him half an hour to row to a place and back. How far is the place? Let the place be d kilometers. D downstream 3 plus 0.6, D upstream 0 minus 3 minus 0.6 is equal to half an hour. So D by 3.6 plus D by 2.4 is equal to 1 by 2. Simplifying, you get 5 by 7.2 is half, or distance is equal to 3.6 by 2 is 3.6 by 5 is 0.72 kilometers or 720 meters. Upstream and 22 kilometers downstream in 5 hours. Also, he can row 20 kilometers upstream and 27.5 kilometers downstream in 6.5. Find the rate of the current and the speed of the man in still water. Let the speed of man in still water be x. Then the first equation, 15 kilometers upstream x minus y, 22 downstream x plus y is equal to 5 hours, and 20 kilometers upstream and 27.5 downstream is equal to 6.5. You can multiply the equation 1 by 4 to get 60 by x minus y plus 88 to x plus y is equal to 20. Equation 2 by 3, 60 by x minus y plus 82.5 by x plus y is equal to 19.5. Subtracting, you get 5.5 by x plus y is equal to half, which gives you x plus y is equal to 11. Substituting in 1, x minus y is equal to 5. Therefore, x is 8 and y is 3. Thus B. A gives B a start of 80 meters. How far must be the winning post be for the race to end in a tie? Speed ratio. A is to B. 1, 2 by 3 is to 1. That is 5 by 3 is to 1 or 5 is to 3. Relative speed is 5 minus 3 is 2 parts. A gives B a start of 80 meters. So 2 parts is 80 meters, 5 parts, 200 meters. The winning post must be at 200 meters, 6 kilometers per hour. If A gives B a start of 4 meters and still beats him by 12 seconds, what is the speed of B? Time taken by A to run 100 meters. 60 seconds. Time taken by B to run 96 meters. Because A beats him by 12 seconds. And B gets a distance of 4 meters. So, speed of B, 96 meters covered in 72 seconds. That will be 4 by 3 or 1.33 meter per second. Start at the same time from the same point and are running around a circular track of length 100 meters with speeds of 25 meters per second and 20 meters per second. If they are running in the same direction, how much distance will the faster man have covered when they met again for the first time? Let's draw a sketch of circular track. A and B running in the same direction. A with the speed of 25 meters per second, B with the speed of 20 meters per second around a circular track of 100 meter circumference. So, when will A overtake B? The rule is find the relative speed in the same direction and time taken to complete one round with that speed. So relative speed in the same direction is 25 minus 25 meters per second. So time taken to cover 100 at the rate of 5 will be 20 seconds. So distance covered by A in 20 seconds will be 20 into 25, 500 meters. Start at the same time from the same point and travel in the same direction around a circular track of circumference 100 kilometers with speeds of 20 kilometers per hour, 25 kilometers per hour and 50 kilometers per hour respectively. Find when will they meet for the second time at the starting point. The rule is find the time taken by each to complete one round. Then the required time is their LCM. Time taken by A to cover 100 kilometers at 20 is 5 hours. Time taken by B is 4 hours. Time taken by C is 2 hours. LCM of 5, 4 and 2 is 20 hours. Therefore, they will meet for the second time at 2 into 20, 40 hours. Around a circular track of length 1.5 kilometers. A walks at the rate of 200 meters per minute and B at the rate of 140 meters per minute. If they both start at the same time from the same point and walk in the same direction, when will they be together again for the first time and when will they be together for the first time at the starting point? Let's take it as 1 and 2. Rule. Find the relative speed in the same direction and time taken to complete one round with that speed. The same direction, relative speed is difference of speeds. So time taken is 1500 at 60 will give you 25 minutes. Second, find the time taken by each to complete one round, and the required time is their LCM. Time taken by A is 7.5 minutes. Time taken by B 70/7. LCM is LCM of 15/2 and 70/7. LCM of 15 and 75 by HCF of 2 and 7, which will be 75 minutes. Around a circular track of circumference 50 kilometers, A speed is 54 kilometers per hour and B is 36 kilometers per hour. If they start in the opposite direction, when will they be together again for the first time, and when will they be together again at the starting point for the first time? First one, rule. Find the relative speed in the opposite direction and the time taken to complete one round with that speed. Relative speed is 54 plus 36, 90 kilometers per hour. Time taken second one. A has to cover 50 kilometers more than B to meet the starting point. So time taken 20/18 or 25/9 or that is 500 by 3 minutes. Option is C. Kilometers per hour in still water. It takes 2 hours 30 minutes to row to a place and come back. The speed of the stream is 2 kilometers per hour. How far is the place? So relative speed upstream x minus y, 4 minus 2 is 2 kilometers per hour. Relative speed downstream is x plus y, 4 plus 2 is 6 kilometers per hour. Let the distance covered be d. Then d by 6 plus d by 2 is equal to 2.5. Solving, we get d is equal to 3.75 kilometers. Destination at a speed of 60 kilometers per hour and the remaining at 80. In the return journey, it travels at an average speed of 60 kilometers per hour, then the average speed for the entire journey. Let the distance covered one way be 2x. Therefore, total distance covered is 2x plus 2x, 4x. Average speed is given by total distance by total time. Total distance is 4x, total time is x at 60, x at 80 and 2x at 60. Cancelling x, you get LCM of 240, 4 and 3, 8. That is 4 into 240 by 15, which will give you 64 kilometers per hour. If a person travels at a speed of 80 kilometers from A to B, and returns to A at 60 kilometers per hour, then his average speed is, since distance covered is same on either direction, the average speed is 2 into xy by x plus y, where x and y are the speeds on either direction. You get 120 into 80 by 140, simplifying you get 68 4 by 7 kilometers per hour. Journey at 80 and remaining 3 hours at 60 kilometers per hour, find the average speed. The average speed is total distance by total time. So 400 plus 180, 580 is covered in 8 hours, or the speed is 72.5 kilometers per hour. Arjun, driving at 4/5 of his usual speed, reaches home 15 minutes later than usual time. What is the usual time? Speed ratio, we look at now versus usual time. Now is 4/5, usual is 1, so 4 is to 5. And time ratio will be in the inverse, 5 is to 4. We look at now as is usual, so 15 minutes later now than usual x. So you get 5x is equal to 4x plus 60, or x is 60 minutes, or 1 hour. Beats B by 20 meters and B beats C by 10 meters. Then by what distance A beats C in 100 meter race? Look at A, B and C. When A runs 100 meters, B will run 20 meters less, 80. When B runs 100, C will run 10 meters less, 90. So, if B runs 100 meters, C will run 90 meters. B runs 80 meters, C will run 72 meters. So, when A runs 100 meters, C can run 72 meters, which means A will beat C by 28 meters. Meter Olympic race, Y beats X by 20 meters or 4 seconds. Then find number 1 speed of X, number 2 speed of Y. In a 400 meter race, and Y covers 400, X will cover 20 meter less, that is 380. And Y beats X by 4 seconds, which means X takes 4 seconds to cover 20 meters. That gives you speed of X, 25 by 4 is 5 meters per second. Speed of Y, time taken by Y, by X to cover 400 meters. 400 by 5 is 80 seconds. So time taken by Y to cover 400 will be 80 minus 4 seconds less 76. That gets you speed of Y 400 at the rate of 76, 5.26 meter per second. Akash gives a head start of 25 meters to Arjun and wins the race by 50 meters or 15 seconds. Then find the speed of Akash. When Akash runs 500 meter race, Arjun will run 500 minus head start again minus 50. So you'll cover only 425 meters. Which means Arjun takes 15 seconds to cover 75 meters. So speed of Arjun 75 by 15, that is 5 meters per second. From there you can find the time taken. Arjun to cover 425 meters. 425 by 5 is 85 seconds. That gets us the time taken by Akash. He takes 15 seconds less, so that is 70 seconds. That gets the speed of Akash. He's covering 500 meters in 70 seconds. The speed is 7.14 meters per second. Meter long, moving with the speed of 60 kilometers per hour, to be overtaken by another train of length 400 meters moving at speed of 80 kilometers per hour in the same direction. When a train crosses another or overtakes another train, and the distance covered by each train is equal to sum of the lengths of the two trains. Relative speed in the same direction is difference of speeds. 80 minus 60 is 20 kilometers per hour. That is dividing by or multiplied by 5 by 18 to convert into meter per second is 50 by 9 meter per second. So time taken, distance is sum of the lengths of the train by the relative speed, will give you 650 into 9 by 50, that is 117 seconds. Track is laid between two tunnels A and B of length 3.2 kilometers and 1.6 kilometers respectively. A train of length 200 meters traveling at 20 kilometers per hour enters tunnel A at 7:30 a.m. At what time does the train comes out of the tunnel B if the tunnels are at a distance of 900 meters? Total distance covered by the train is equal to sum of the length of the two tunnels and the distance between them 0.9 and the length of the train, that will be 5.9 kilometers. Speed of train is 20 kilometers per hour. So time taken 5.9 by 20, 0.295 hours from 7:30.